In this module, we will focus on visualizing data with error bars and then show these uncertainties associated with the data. And then we'll use a weighted fit, which will adjust the fit parameters based on the uncertainties on each of the data points. First, we begin with a file where we now have three columns: the independent variable, the dependent variable, and then the uncertainty in the dependent variable. Again, we will check to make sure that we have the correct file and location using the file print command. And then we will import the data, again removing the first line of the data. We can now plot this data with error bars, but we need an additional Mathematica package in order to create this plot. We use the needs error bar plots command in order to import this package, and we can now use the error list plot use our data as the parameter to create the plot. As before, we add the graph options to create a presentation quality plot. Now we do weighted curve fitting. The first thing we need to do is separate out both the data and the uncertainties in the data in order to use the nonlinear model fit. First, we'll create a fitted data variable where we use our data, and we are going to pull out the first two columns. All parameter tells Mathematica to use all rows, and the 1 double semicolon 2 tells it to use the first two columns. The second thing we need to do is tell Mathematica what to use as the fit weights, which is actually the inverse of the square of the uncertainties. To do this, we do 1 divided by our data, all the rows, and the third column, which is the uncertainty column, squared. Now the only modification to the fit command will be to add in not only the weights, but also a second parameter which tells Mathematica that our weights are measurement uncertainties and treats them a little bit differently than if they were just statistical uncertainties. That is adding weights, and we give it the parameter our fit weights, and the variance estimator function, and that's parenthesis 1 space ampersand and parenthesis. Now, as before, we can see our best fit parameters and our parameter errors. And you'll notice that these uncertainties are slightly different than the uncertainties, even though the data is the same as the previous module. And finally, we can add our same formatting to our plot to combine both the data plot and the fitted weight plot together, creating a final fitted weight plot with uncertainty and error bars.